Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics in the chapters of mechanical actions, equilibrium of body and Archimedes subtrust. This exercise was a previous one in the Breve exams in 2008 first session, third exercise. The title of this exercise is Density and Flotation. The object of this exercise is to study the influence of the density of a liquid on the flotation of a solid immersed in this liquid. In order to do this, we consider a solid cube S of mass m is equal to 0.9 kilograms. So the mass is given in the SI. And of side A is equal to 10 centimeters. Knowing that centimeters is not the SI unit of length, in order to convert from centimeters to meter, we divide by 100. Then 10 divided by 100. Then the side is given by 0.1 meters. Since this solid is classified as a regular shape, which is a cube, then using this side, we can determine its volume. Now part 1, characteristics of S. Number 1, verify that the volume of S is V is equal to 10 to the power minus 3 meter cube. So as we have said that the volume can be calculated from the volume from the side of this cube, so V is equal to 8 to the power 3. Then plugging the side in the SI, so 0.1 to the power 3. Plugging this on the calculator, then the volume is given by 1 times 10 to the power minus 3. Since the side is expressed in the SI, so the volume V will be expressed in the SI, which is meter cube. Then the volume of this cube is given by 1 times 10 to the power minus 3 meter cube. Now number 2, deduce the density of S is rho is equal to 900 kg per meter cube, and by deduce it means that we need to use the previous part. In number 1 we have determined the volume and we know the mass of this solid, so density can be calculated using mass over volume. Now the mass is given by 0.9, whereas the volume is given by 1 times 10 to the power minus 3. Plugging this fraction on the calculator, then the density is given by 900. Since both the mass and the density are expressed in the SI, so the unit of rho will be in the SI, which is kilogram per meter cube. Then the density of this solid is given by 900 kilogram per meter cube. So we have the volume, we have the density. Let me write here that the density is given by 900 kilogram per meter cube. Moreover, in number 3, they are telling me to calculate the weight of S. So here, because they mentioned the liquid, it's important to differentiate between two types of weight, the real weight and the apparent weight. Since they didn't mention anything about the apparent weight, so we are concerned about the real weight. And here, by calculate the weight W of S, they are referring to the magnitude of the weight, which is given by W is equal to M multiplied by G. The value of M is given by 0.9, whereas the value of G is given by 10. Plugging this on the calculator, then the weight is given by 9. Since both the mass and the G are expressed in the SI, so the value of W will be in the SI, which is in newtons. So the weight is given by 9 in newtons. So this weight corresponds for the solid S. Now in part 2, S is in oil, we immerse S completely in oil, so this is important. By completely here, it means that the volume of the immersed part is equal to the total volume of the solid S. Of density ρ1 is equal to 800 kg per meter cube. Number 1, calculate the value F1 of the Archimedes upthrust exerted by oil on S, and here by the value it means the magnitude. So let me do here a small sketch in order to understand what's happening. So suppose that oil is contained in this container. So this container contains oil, and here they are telling me that S is completely immersed in oil, and the shape of the solid S is given by a cube. Now the shape actually is not important. So this is the solid S completely immersed in oil. Now number 1, we are interested in determining the value F1 of the Archimedes upthrust. Okay, before calculating the magnitude of F1, let's discuss the different forces acting on the solid S. So because it has a mass, then it will be directly subjected to the weight, to the real weight, which is acting vertically downward. And because we have a liquid and they mentioned the Archimedes upthrust, so this solid will be subjected to the other force, which is the Archimedes upthrust force acting vertically upward. So this is F1. Now, moreover, since we are interested in determining the value of F, let's discuss the different methods that allows us to determine the magnitude of F. So the first trivial method is the difference between the real weight and the apparent weight. We know the value of the real weight, however, we don't know the value of the apparent weight, so this method here doesn't hold. Now, the other method is given by the condition of equilibrium, which is given by that W vector plus F vector is equal to 0 vector. But since here they told me that we immerse S completely in oil, so we don't know whether this solid is floating inside the oil or floating at the surface or contact with the bottom of the container, so we cannot use the condition of equilibrium. Therefore, we are left with the following method, which is given by that the value of F upthrust is equal to the density of the liquid times the volume of the immersed part times the G. Now, in order to determine the value of F upthrust, we need to know the value of G. So, okay, here we know the value of G to be given by 10 Newton per kilogram, so this is okay. And we know the density of the liquid, which is oil, 900 kilogram per meter cube. Now it's left to know the volume of the immersed part. But here, since they are telling me that Vi is equal to V, and we know already the value of V, so F upthrust can be calculated. But first, let's justify that since S is completely immersed in the liquid, then in this case, the volume of the immersed part is equal to the total volume V of the solid S. Now we are ready to calculate the magnitude of F upthrust, which is denoted by F1. Notice that I didn't construct a triangle for this formula because this is the quantity that we want to calculate. Is equal to the density of the liquid, which is denoted by ρ1, multiplied by the volume Vi, so replacing Vi by V, multiplying it by the value of G. Now the value of ρ1 is given by 800. Sorry, here, previously I have said that the density is 900, but actually it is 800. 900 for the solid S, so 800 for the oil. And the value of V is given by 1 times 10 to the power minus 3. And the value of G is given by 10. Plugging this on the calculator, then the value of F1 is given by 8. Since all of these quantities are expressed in the SI, so the value of F1 will be expressed in the SI, which is in newtons. So the value of F1 is given by 80 newtons. What does F1 represent? It is the magnitude of the Archimedes upthrust force F1 vector exerted by oil by which liquid? By oil on the solid S. So here let me write that F1 is equal to 80 newtons. Now we are in number 2. By comparing W and F1, then let's do the comparison between the magnitudes of W and F1. W is equal to 90 newtons and the value of F1 is equal to 80 newtons. And by compare, it means we need to say whether W is greater, equal, or less than F1. And in this case, it's obvious that W is greater than F1. Deduce that the solid S sinks to the bottom of the liquid container, and by deduce it means we need to use the comparison just previously before. Knowing that W is equal to 90 newtons, which is greater than the value of F1, which is given by 80 newtons, taking into consideration that W is acting on that the action of W vector is vertically downward, while the action is of F is vertically upward. And from this equation, one can say that the action of W is greater than F1. For this reason, the solid S will sink. Now let's say since the magnitude of W is greater than that of F1, then S will sink to the bottom of the container. Now part 3 of this exercise, so here let me say that the result is, okay, the solid will sink. Now S is in water, okay, so here oil is replaced by water. We repeat the experiment by immersing S completely in water, okay, this is important. Then in this case also we have that Vi is equal to V of density ρ2 is equal to 1000 kg per meter cube. Number 1, calculate the value of F2 of the Archimedes upthrust exerted by water on S. Now, performing the same previous discussion and the different methods in calculating the value of F, we will be left with the following method, that F upthrust is equal to the density of the liquid times the volume of the immersed part times G. Now, and we need to justify that the volume of the immersed part is equal to the total volume V, because here the solid S is completely immersed in water. Then let's say, since S is completely immersed in the liquid, then in this case the volume of the immersed part is equal to the total volume V of the solid S. Knowing that we are interested in determining the magnitude of F, which is denoted by F2, which is equal to the density of the liquid. Here the liquid is represented by water of density denoted by ρ2, multiplied by the volume of the immersed part, which is the total volume V, multiplied by the value of G. Now the value of ρ2 is given by 1000. The value of V is given by 1 times 10 to the power minus 3. And the value of G is given by 10. Plugging this on the calculator, then the value of F2 is given by 10. Since all of these quantities are expressed in the SI, so the value of F2 will be expressed in the SI, which is in newtons. So the value of F2 is equal to 10 in newtons. And let me write here that the value F2 is equal to 10 in newtons. Now just a side remark, what's the difference between here the value F1, the value of F1, and here the value of F2, since both of them represent the magnitude of the Archimedes upthrust. Here we must be very careful that F1 corresponds to the Archimedes upthrust exerted by oil, whereas the value of F2 corresponds to the value of the magnitude of Archimedes upthrust exerted by water, knowing that we have replaced oil by water. Now number 2, deduce that the solid S floats on the surface of water. So notice that in this experiment we are repeating the same steps of part 2 of this exercise, and by deduce it means that we need to use the previous part. Now comparing these two experiments, we notice that here in number 2 we have done the comparison between W and F1. So first, in order to deduce, let's do the comparison between W and F2, knowing that W is equal to 9 in newtons and the value of F2 is given by 10 in newtons, and by compare it means that we need to say whether W is less, greater, or equal to F2, and in this case it's obvious that F2 is greater than W. Now referring back to this figure, we know that the value of F2 is given by 10 in newtons, which is greater than the value of W, which is equal to 9 in newtons. Now knowing that the weight acts vertically downward while F acts vertically upward, and from this equation we can say that the action of F2 is greater or stronger than the action of W. For this reason F will float to the surface of the liquid. Then let's say, since the magnitude of F2 is greater then that of W, then S floats on the surface. So here the result is given by that S will float. Now part 4, condition for flotation, by comparing row 1 and row 2 to row. So what's meant by this? Comparing row 1 and row 2 to row. So we need to do the comparison between row 1 and row on one side, and a comparison between row 2 and row on the other side. But why? So by comparison, give the condition that must be satisfied by the density of a solid and the density of a liquid for a solid to float on the surface of the liquid. So we need to determine the condition that must be satisfied by the density of a solid and the density of a liquid for the solid to float on the surface of the liquid. So we are interested in the flotation, and the flotation refers to the third part of this exercise, because here S floats. So no need to compare row 1 and row 2. However, we will compare row 2 and row, because in the case of the flotation, the density is given by row 2, which corresponds to that of water. So let's do the comparison between row 2 and row only. Knowing that the value of row 2 is given by, so let me say that knowing that the value of row of the solid is given by 900 kilogram per meter cube, and row 2 is given by, in this case, 1000. Then the value of row is less than that of row 2. This is the comparison. And let's say then the condition that must be satisfied by the density of a solid and the density of a liquid is given by, so here this is the density of the solid and this is the density of the liquid. So in order for the solid to float on the surface of the liquid, from this condition or inequality, the density of the solid must be less than the density of the liquid. The density of the solid must be less than the density of the liquid. So this is the condition that must be satisfied. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.